the slope formula is one of the first things that you may have learned in an Algebra 1 course when you started graphing lines, and there it is. Um, Basically, what it is, it's measuring, how far you're rising versus how far you're running, which that's a way rise over run. So rise is like how far you're moving up and down, up or down. And the run is how far you're moving left or right. It's always the y's over the x's. Y's, rise, they rhyme. That's how I try to tell people to remember that. It's always the y's on top. Um, Here it's more, it does matter more how you set up the subtraction. Again, it doesn't matter which points, y coordinate you start with. I mean, I could say just as easily it's y1 minus y2 over x1 minus x2. That would also be sufficient. It's just so that, whichever point I'm getting the y from, I should be getting the x from that same point in the first position down there. I don't want to mix them up along the way and end up getting the wrong value. Find the slope of the line that passes through the following coordinates. So, I mean, if you have a graph and if you want to plot the points, I mean, 4, 6 would be right here. 7, negative 4 would be right here. I could literally count, I'm moving up from negative 4 to 10, that's negative 4 to 6, that's 10 units. And I'm moving left 3 units. So I could say that the slope here is negative 10 thirds. And we usually leave them written in fraction form so you can tell what the rise and the run is. Could you have used the slope formula? Sure. If you used the slope formula, you would have gotten the same thing. You would say, okay, well, I have negative 4 minus 6 over... Now, since I chose this one first, I got to choose the 7 first. And I get a negative 10 over 3, which is negative 10 thirds again. So it doesn't matter if you don't have a graph in front of you, it's kind of pointless to count. Or if you get a point that's like, okay, what are the coordinates of this point right here where it's not crossing through one of the grids? That gets to be a little bit more difficult, and you have to sometimes, use the point and calculate it using the formula rather than using, the lines here. But, you can certainly do it that way. I mean, 2, 7, here's 2, where 2, 7 is. This was nothing. I just was trying to make a point with that. Negative 6, negative 1 would be right here. So again, if I go from negative 1 to 7, that's 8 units. And when I go from negative 6 to 2, that's 8 units. So basically, the slope of this line is 1 over 1, or just 1. For C and D, it's important to see what's going on with these in both formats. If I plot 4, 7 and 8, 7, the line that passes through them is right here. It's a horizontal line. And if I were to use the slope formula on that, I'll come up here with it. My slope would be 7 minus 7 over 8 minus 4, which is 0 over 4, which is 0. 0 divided by a number is 0. So it seems as though if I have a horizontal line, my y-coordinates are going to cancel each other out on top and make it a 0. So I'm going to have a slope of 0. So we say that the slope of a horizontal line is 0. When I look at D, 6, negative 2, so I'm looking at right here, 6, 3, this is a vertical line. If I do its slope, I'm going to have 3 minus negative 2 over 6 minus 6, which is 5 over 0. Now we're not allowed to divide 5 by 0. Um, actually it's an infinitely big number if you try to do that, but it's really not defined because we really don't know what infinity is either. So this is undefined. And you would see that would happen with any vertical line, so the slope of a vertical line is undefined.